Hello everyone, my name is Adish and I welcome you all in the very second lecture on Sylvester's theorem. Okay, so first of all let us revise the working rule of the previous of the Sylvester's theorem, and then we'll see the problem, because to solve this problem we need working rule. Okay, so what do you remember the steps? So just pause down the video for a few seconds, recollect all the steps required to solve the problem on Sylvester's theorem, and then play the video again. So I hope you have recollect all the steps that which are required to solve the problem on Sylvester's theorem. So let us recollect. What is the first step? Find out eigenvalues. Correct. What is the second step? This is nothing but working rule. What is the second step? Write phi of lambda and find phi dash of lambda. Very good. What is the third step? Do you remember the third step? Third step is you have to find out the adjoint of lambda I minus a. Is it? Number 4, what was the fourth step? Fourth step was write down the what? Sylvester's coefficient. Z of lambda r is equal to adjoint of lambda I minus a upon phi dash of lambda, and find out z of lambda 1, z of lambda 2. Okay. Next, number 5, what is it? Write p of a and find p of lambda 1 and p of lambda 2. Is it? And what was the last step? Use Sylvester's theorem. Use Sylvester's theorem to get the result, right? To get the result. So these were the working rule, and I hope you have remembered these working rules. In the last lecture also we have discussed this. Okay, and one remark I would like to make before we start with the example. Okay, for eigenvalues you have to make use of the equation lambda I minus a, which is very important. And another remark about this, you can apply Sylvester's theorem only when the eigenvalues are distinct. Okay, so let us see what problem we have to solve. So the problem says, using Sylvester's theorem, find a to the power n if a is equal to cos alpha sin alpha minus sin alpha cos alpha. Okay, so let us solve this problem. So first step is we have to start with the given thing and find out the eigenvalues. So let a is equal to, what is it? Cos alpha minus sin alpha cos alpha. So we have this matrix A and we have to find out the eigenvalues. So you can write eigenvalues are given by what? Determinant of lambda I minus a equal to 0. Very IMP step is this. Okay, so just write it down. Lambda minus cos alpha, then minus sin alpha, then minus this become plus sin alpha, and this is lambda minus cos alpha is equal to 0. Okay, now this is again a 2 by 2 matrix. Okay, so what we need to write down? We just need to write down lambda square minus s1 lambda plus determinant of a equal to 0, following plus minus plus, and if there are term minus. Okay, what is s1? S1 is nothing but the trace of the matrix. What is trace? Sum of the diagonal elements. So what is S1? S1 is cos alpha plus cos alpha, that is 2 cos alpha. So you can write lambda square minus 2 cos alpha lambda plus, what is the determinant? Cos into cos, cos square alpha minus plus sin square alpha. So we are getting cos square alpha. Wait, cos square alpha plus sin square alpha is equal to 0. And this is well known identity. बच्चा बच्चा जानता है ये identity का आंसर क्या आता है. What is it? 1. Correct. Therefore, lambda square minus 2 cos alpha lambda plus 1 is equal to 0. Okay, now our objective is to find out the roots of this. This is not, we cannot factorize this function. Okay, so we have to go with the basic. If you have an equation of the type like, let me take a different pen. If you have an equation of the type like this, ax square plus bx plus c equal to 0, and if you are not able to find out its factors, so what you need to find out? You can find out its factor by using the very famous formula x equal to minus b plus minus under root of b square minus 4ac upon twice a. Correct? So we are going to make use of this formula to get the roots of this equation. Okay, so can you help me out in finding out this? So what is it? We need to find out. This is in terms of lambda. So I will find out lambda. Lambda is equal to minus b. What is b? Here a is 1, b is a is 1, b is minus 2 cos alpha, and c is 1. This is a, this is b, and this is c. Okay, so apply by using this formula. So what is it? Minus minus plus 2 cos alpha plus minus under root of, what is b square? Minus 2 cos alpha square, 4 cos square alpha minus b square minus 4. What is a? 1. What is c? 1. So this is just 4. 4 into 1 into 1 upon 2a. What is a? 1. So this is 2. Okay. So what we'll be getting? We are getting, this is same as, now see, I can take under root 4 common, so under root 4 becomes 2. Okay, so it is like 2 cos alpha plus minus, I am taking under root 4 outside, that is 2 into under root, what is remaining? Cos square alpha minus 1 upon 2. Okay, now you can take 2 common from the numerator and get cancelled with this. Okay, so once you do it, we'll be getting our eigenvalues. So we are done with the first step, that is lambda is equal to 2 get cancelled. So what is it? Cos square, or if you want me, I can take 2 common, then you can write cos alpha plus minus, what is it? Under root of cos square alpha minus 1. Cos square alpha minus 1 is under root of minus sin square alpha. Okay, upon 2. So this 2 get cancelled with this 2. This get cancelled with this, and we remain with, what is it? We remain with cos alpha plus minus, what is under root of sin square alpha? Sin alpha. And what is under root of minus 1 is iota. So what eigenvalues we are getting? Therefore lambda 1 is equal to cos alpha plus I sin alpha, going with the positive first, and then lambda 2 is equal to cos alpha minus I sin alpha. Okay, are the roots distinct or identical? The roots are distinct, different eigenvalues, plus and minus. Okay, so we can just see that this is plus and this is minus, so we have distinct eigenvalues, and if the eigenvalues are distinct, we can apply the Sylvester's theorem. So this completes step number 1. So you can just write one sentence here, as eigenvalues are distinct, therefore Sylvester's Sylvester's theorem is applicable. Okay, so this completes the first step. Now what is the second step? The second step says write down phi of lambda. So what is phi of lambda? Yes, you just have to go through the equation. So phi of lambda is lambda square minus 2 cos alpha lambda plus 1. Is it? Plus 1. Then if you have phi of lambda, you can find out phi dash of lambda implies. What is phi dash of lambda? Derivative of this with respect to lambda is 2 lambda minus 2 cos alpha. Okay, so we got 2 lambda minus 2 cos alpha. Okay, so phi dash of lambda is 2 lambda minus 2 cos alpha. Okay, so this is phi of lambda and phi dash of lambda. Now let us find out the adjoint of this. Completes the second step. Now the third step, adjoint of lambda I minus a. So what is adjoint of lambda I minus a? So adjoint of lambda I minus a is swap the diagonal elements, that is lambda minus cos alpha, lambda minus cos alpha, and give minus sign to the non-diagonal element. So this is minus sin alpha, this is plus sin alpha. If you remember, we have this matrix. Okay, so this is lambda minus cos alpha, sin alpha, minus sin alpha, and lambda minus cos alpha. So we have this adjoint. So this completes the step number 3, right? Now we have to find out z of lambda r. So do you remember what is z of lambda r? What is z of lambda? Therefore, z of lambda r is equal to, what is it? Z of lambda r is nothing but adjoint of lambda I minus a upon phi dash of lambda. Okay, where lambda is equal to lambda r. So you can substitute the values. We have these values. So what is phi dash of lambda? Phi dash of lambda is this, 2 lambda minus 2 cos alpha, and we have the matrix which is lambda minus cos alpha minus sin alpha, and lambda minus cos alpha. Okay, so we got this. Now don't forget to write lambda equal to lambda r. Okay, now once you get this, find out z of lambda 1 and z of lambda 2. So z of lambda 1, what is z of lambda 1? Put lambda is equal to this, cos alpha plus I sin alpha. So cos alpha minus cos alpha get cancelled, we remain with I sin alpha. Okay, so I will write I sin alpha minus sin alpha, and then I sin alpha. Okay, and this divided by, when you substitute here lambda, so 2 cos alpha get cancelled, so you get 2I sin alpha. Okay, for best way I can write it here, divided by 2I sin alpha, 2I sin alpha. Now what you can do, you can divide it by this. So 1 upon 2I you can take common and divide by sin. So when you divide by sin, what will be getting? I 1 minus 1 I 1 minus 1 I. Okay, likewise you can find out z of lambda 2, where lambda 2 is cos alpha minus I sin alpha. Okay, so what is z of lambda 2? Therefore, z of lambda 2 is equal to, I can write it as, what is it? Lambda minus cos alpha. So what is lambda? Now my lambda is equal to cos alpha minus I sin alpha. So same thing with the negative sign. Okay, so that is what we have. Minus I sin alpha minus sin alpha and minus I sin alpha. Okay, divided by minus 2I sin alpha, because it is 2 lambda, so 2 cos alpha get cancelled, minus 2I sin alpha will be remaining, and then you can write this as again 1 upon 2I and divide by sin. So we'll be getting minus I 1 minus 1 minus I. We'll be getting this 1 upon 2I. Okay, I, and you can remove the minus sign also, so this should be minus. Okay, because we have minus sign, so I along the diagonal 1 minus 1. Okay, once you are done with this z of lambda 2, you need to find out p of a. This completes step number 4. Now P of A is equal to, what is P of A? What is P of A? What is the function? A to the power n. P of A is A to the power n. This implies P of lambda 1. So P of lambda 1 is lambda 1 to the power n. Okay, and what is this? This is nothing but cos alpha plus I sin alpha power n. Cos theta plus I sin theta is e to the power I theta. So you can write this one as e to the power I alpha power n. Or you can write by DMT e to the power I n alpha. If you remember, you can write. If not, then still you have to write I alpha n or I n alpha. Okay. Likewise, you can write for P of lambda 2. So I will be writing P of lambda 2 is equal to lambda 2 power n, which can be written as e to the power. What is cos alpha minus I sin alpha? So it should be minus I alpha power n. This is e to the power minus I alpha n. Okay. So you can write I n alpha also to not get confused. So this is like I n alpha. Okay. Now after getting this, we got all the things. Now make use of Sylvester's theorem to find out the result. So by Sylvester's theorem, therefore by Sylvester's theorem, P of A is equal to summation r is equal to 1 to n. What is n? 2. P of lambda r into z of lambda r. Okay. So what is P of A? For the time being, just write it as P of A is equal to P of lambda 1 into z of lambda 1 plus P of lambda 2 into z of lambda 2. Okay. So what is P of lambda 1? We have found out P of lambda 1 is e to the power I n alpha. Z of lambda 1 we have found out. Do you remember? Z of lambda 1, 1 upon 2I, and in the matrix what we had? I minus 1, 1I plus, what is P of lambda 2? E to the power minus I n alpha. And what is Z of lambda 2? This is 1 upon 2I into, what is it? I 1 minus 1. Okay. Now once you get all these things, just solve this to get the answer. Okay. So what you can do is just stick it inside, and you take it inside, what you will be getting a matrix like e to the power I get cancelled, e to the power I n alpha by 2. Then here e to the power I n alpha by 2I, is it? And then minus e to the power I n alpha by 2i, and then here I times, so this I get cancelled, e to the power I n alpha by 2. Okay, this is the first matrix. Now solve this. So when you solve this matrix, you will be getting I get cancelled, e to the power minus I n alpha by 2. This is minus e to the power minus I n alpha by 2i, and here it is e to the power minus I n alpha by 2i, and here it is e to the power minus I n alpha by 2. Now just the addition, do the addition to get the result. So what is in the left hand side? P of a. What is P of a? P of a is a to the power n. So we are coming in the new page, so we must have a to left hand side, a to the power n is equal to, now add this one. So what you will be getting, e to the power I n alpha, e to the power minus I n alpha by 2, e to the power I n alpha minus e to the power minus I n alpha by 2i, and then e to the power, I can take minus common here, and I can write e to the power I n alpha minus e to the power minus I n alpha by 2. Okay, if not that, see, if you are not taking this, it is like this. It is like this, minus, and this is plus. Okay, now solve the last one, e to the power I n alpha upon, plus e to the power minus I n alpha by 2. Okay, I can write this one as like this also. Okay, now what you can do is you can take minus sign common from here. So when you take minus sign here, it becomes like this. Okay, therefore a to the power n is equal to, do you remember this? This is cos circular function. So this is the formula for cos circular function. So you can write down cos n alpha. This is minus, this is sine circular function. So this is sine n alpha, this is sine n alpha, and this is cos n alpha. Okay, so this is what we wanted to show. Simple. So you just need to remember two formulas that I will write here. Above the margin you can write cos alpha is equal to e to the power I alpha plus e to the power minus I alpha by 2, and for sine, yes, just second, here it is 2i, so I just forget to write I here. Okay, and for sine alpha is e to the power I alpha minus e to the power minus I alpha by 2i. This being the real part, no I is there, and this being imaginary part, there should be I in the denominator. Okay, so this is for alpha. For n alpha it should be I n alpha. Okay, likewise. So this is what we wanted to prove. Okay, so we have taken two lectures on this topic, Sylvester's theorem, and there will be a problem for you to solve as an assignment. So I will be giving you the problems in the next time. Okay, so thank you for watching this learning video. Enjoy learning digitally. Thank you.